Lesson on the Flet library in Python. Part 1, Introduction to Flet. Welcome to a lesson dedicated to Flet, an exciting Python library that allows you to build cross-platform desktop, mobile, and web applications using familiar Python syntax. What is Flet? Flet is a UI framework that enables developers to write beautiful and interactive applications using only Python. Unlike other frameworks such as PyQt or Kivy, Flet uses a client-server model where the Python code runs as a server, and the UI is rendered in a browser or a native Flet wrapper app for a specific platform. This means you can create native desktop applications for Windows, Mac OS, Linux. Create web applications that can be accessed via a browser. Create mobile applications for Android and iOS. All of this from a single Python codebase. Why Flet? Ease of use, no need to learn HTML, CSS, JavaScript, or platform-specific languages. Everything is written in Python. Fast development, thanks to its simple API and hot reload, you can quickly iterate and see changes in real time. Cross-platform, the same codebase works everywhere. Modern UI, Flet uses Flutter under the hood, allowing for beautiful and responsive interfaces. Python backend, ability to easily integrate complex backend logic, databases, APIs, machine learning, directly into your app. Basic installation. To get started with Flet, you'll need Python 3.7 Plus and Flet itself. Installing Flet is very straightforward using pip, bash. Pip install Flet. Core Flet concepts. Page, this is the main canvas of your application, where all UI controls, widgets, are placed. Every Flet application typically has one or more pages. Controls, these are the building blocks of your user interface, buttons, text fields, images, columns, rows, and much more. They are referred to as controls in Flet terminology. App, the foot app function runs your Flet application. You pass it a function that defines your page's content. Part 2, 10 examples of Flet usage in Python. Let's look at 10 detailed examples to understand how to build applications with Flet. Example 1, Hello World, basic text. This example shows the simplest Flet application that just displays text. Step 1, define the main function to create the page. Step 2, set the title for the application window/tab. Step 3, create a text control. Step 4, add the text control to the page. Step 5, update the page to display the changes. Step 6, run the application, passing it the main function. Step-by-step explanation. Import Flet as ft. Imports the Flet library and gives it the alias ft for convenience. Def main, page, foot page defines the main function, which is the entry point of our application. Flet automatically passes a page object, the application page, to it. Page.title equals hello, Flet, sets the title of the application window or browser tab. Hello_text equals foot text, hello, world, creates an instance of the text control. We pass it the text, hello, world, and set its size and weight. Page.add, hello_text adds the created text control to the page. Page.update, this is a crucial step. It tells Flet that the page has been modified. And the UI needs to be redrawn to reflect these changes. Without update, you won't see your text. Foot app, target equals main runs the Flet application. Target equals main specifies that the main function should be called to build the page. Example 2, adding a button and handling clicks. This example demonstrates how to create a button and react to its presses. Step 1. Create a variable for the counter. Step 2. Create a text control to display the counter. Step 3. Define the event handler function for the button click. Increment the counter. Update the text control's value. Update the page to display changes. Step 4. Create the button and bind the handler to the on_click event. Step 5. Add the text and button to the page. Step-by-step explanation. Page.counter equals 0. We add a counter property to the page object to store the counter's state. His is a convenient way to manage application data. Counter_text equals foot text. Create a text control that will display the current counter value. Def on_button_click. Define a function that will be called every time the button is clicked. Flet passes an event object, to this function. Page.counter plus equals 1, increment our counter. Counter_text.value equals f, counter, page.counter, important. To change the displayed text, we must modify the value property of the counter_text element. Simply changing page.counter will not update the UI. Page.update, call update, again to tell Flet to redraw the page with the new counter value. My_button equals foot elevated button, click me, on_click equals on_button_click create the button. Elevated button is a button with a shadow. The key part here is on_click equals on_button_click, which links the on_button_click function to the button's click event. Example 3, using column and row for layout. This example shows how to arrange controls vertically and horizontally. Step 1, create controls. Step 2. Use column for vertical arrangement. Align to the center along the main axis, vertical. Step 3. Use row for horizontal arrangement. Distribute items evenly with space around them. Spacing between items. Step 4. Add both layouts to the page. Step-by-step explanation, Text 1, Text 2, Button 1, Button 2, just create some basic elements for demonstration. Vertical underscore layout equals foot column, dot. Create a column container. The list inside, dot, contains all the elements that will be arranged vertically, one below the other. Alignment, determines how items are aligned along the main axis, for column. This is vertical. Center centers them. Spacing, defines the space between items in the column. Horizontal underscore layout equals foot row, dot. Create a row container. The list inside, dot, contains all the elements that will be arranged horizontally, side by side. Alignment, for row, this is horizontal alignment. Space underscore around distributes space evenly around items. Spacing, defines the space between items in the row. Page.add, vertical underscore layout, horizontal underscore layout add both containers to the page. By default, page.add, adds elements vertically, so vertical underscore layout will be above horizontal underscore layout. Example 4, User Input, Text Field. This example shows how to get text input from the user. Step 1, create a text field for input. Hint for the user. Example text. Field width. Rounded corners. Step 2, create a text control to display the output. Step 3, define the button's event handler function. Check if the field is not empty. Update the page. Step 4. Create the button. Step 5. Add the elements to the page. Step-by-step explanation. Input underscore field equals foot text field. Dot create a text field. Label. Text displayed above the input field. Hint underscore text. Example text inside the field that disappears upon typing. Width. Border underscore radius. Styling properties. Output underscore text equals foot text. Create an empty text control that will be updated. Def greet underscore user. Event handler for the button. If input underscore field dot value, get the current value from the text field via its dot value property. Output underscore text dot value equals. Update the text in output underscore text. Page dot update. Update the UI. Example 5, Checkbox and State Management. This example demonstrates using a checkbox and changing the UI based on its state. Step 1. Create a text control that will change. Step 2. Define the event handler function for checkbox state change. E.control refers to the control that triggered the event, checkbox. Update the page. Step 3. Create the checkbox. Initial state, unchecked. Step 4. Add the elements to the page. Step-by-step explanation. Status underscore text equals foot text, dot text to display the checkbox status. Def on underscore checkbox underscore change, event handler for the on underscore change event of the checkbox. E.control dot value. Unlike a button, for a checkbox, the new state, checked/unchecked, is passed in E.control dot value. If true, the checkbox is checked, if false, it's unchecked. My underscore checkbox equals foot checkbox, dot create the checkbox. Label, text next to the checkbox. Value, initial state of the checkbox, true or false. On underscore change, bind the handler to the state change event. Page.update, update the UI. Example 6, Slider for numeric input. This example demonstrates how to use a slider to select a numeric value within a given range. Step 1. Create a text control to display the slider's value. Step 2. Define the event handler function for slider value change. e.control.value contains the current slider value. Step 3. Create the slider. Minimum value. Maximum value. Number of divisions, for snapping. Initial value. Display current value as a tooltip. Step 4. Add the elements to the page. Step-by-step explanation. Slider underscore value underscore text equals foot text, dot text to display the selected value. Def on underscore slider underscore change, event handler for the on underscore change event of the slider. e.control.value, contains the current numeric value of the slider. We cast it to int for display. My underscore slider equals foot slider, dot create the slider. Min, max, define the value range. Divisions, divides the range into a specified number of steps, allows snapping to these values. Value, initial value of the slider. Label equals, value, shows a tooltip with the current value when dragged. On underscore change, bind the handler. Page.update, update the UI. Example 7, Counter App Example. This example demonstrates the basic concepts of Flet, creating a page, adding controls, arranging them using row and column, and handling events, button clicks, to update the UI. Goal, create a simple counter application with buttons to increment and decrement a number, and a text field to display the current value. Not used in this specific example, but often needed for file operations. Step 1. Configure the main application page. Set the title of the application window/tab. Align content to the center of the page. Step 2. Create a variable to store the counter state. Initial value of the counter. Step 3. Create a function to handle button clicks. This function will be called when the plus and dash buttons are pressed. Get the current counter value, converting it to an integer. Check which button was pressed based on its text. Increment the value if the plus button is pressed. Decrement the value if the dash button is pressed. Update the text field with the new value. Update the page to reflect the changes in the UI. Step 4. Create the buttons. Create a button to decrement the value. Text on the button. Function to be called when clicked. Create a button to increment the value. Text on the button. Function to be called when clicked. Step 5. Organize elements on the page using row and column. Create a horizontal row, for the buttons and text field. Align elements to the center of the row. Spacing equals 10 adds 10 pixels between elements. Dash button. Counter text field. Plus button. Create a vertical column to arrange all elements. This allows us, for example, to add a title above the counter. Title. Row with buttons and counter. Align column content horizontally to the center. Space between column elements. Step 6. Add the main element to the page and update the UI. Add the column, which contains all our widgets, to the page. On the first launch, update the page to display all elements. Step 7. Run the Flet application. Run the application, passing our main function as the page handler. View equals foot web underscore browser opens the application in a web browser, convenient for testing. To run as a desktop application, you can simply use ft.app, target equals main. Detailed step-by-step explanation of each stage. Importing necessary modules, import Flet as FT and import OS import Flet as FT. This is the standard line for importing the Flet framework. We use as FT for convenience, so we can write foot page instead of Flet page. Import OS, this module is for interacting with the operating system, for example. To check for file existence, os.path.exists. It's not used in this specific counter example but was necessary for the image example we discussed previously. Defining the main function main, page, foot page. All Flet applications start with a main function that takes one argument. A page object of type foot page. This page object represents your application's window or tab and allows you to add controls to it. Page configuration, page.title, page.vertical_alignment page.title equals simple Flet counter, sets the text that will appear in the application window's title bar or browser tab. Page.vertical_alignment equals foot main axis alignment.center, this property determines how the page's content will be aligned vertically. Foot main axis alignment.center centers all content vertically. Creating a state variable, current_value equals foot text, 0, size equals 30. We create an foot text object. This is a widget that displays text. Initially, it shows 0. Size equals 30, sets the font size of the text. Important, in Flet, if you want a control to change, you must store it as an object. Like current_value here, and then update its properties, e.g. current_value.value. Creating an event handler function on_button_click, e. This function will listen for button clicks. E, short for event, is an event object that Flet passes when on_click is triggered. Count equals int, current_value.value gets the current text value from current_value. And converts it to an integer so that mathematical operations can be performed. If e.control.text equals plus, we use e.control.text to determine which button was pressed. E.control refers to the widget, button, itself that triggered the event. Count plus equals 1 or count dash equals 1, increments or decrements the counter value. Current_value.value equals str. Count updates the value property of the text widget with the new counter value. It's important to convert the number back to a string, as foot text displays strings. Page.update, this is a crucial step. Flet does not update the UI automatically. After any state change to a widget, e.g. current_value.value, you must call page.update. Or widget.update, if updating a specific widget, for the changes to be reflected on the screen. Creating buttons, foot elevated button -_button equals foot elevated button, text equals dash, on_click equals on_button_click creates a button with the text dash and binds the on_button_click function to it to handle clicks. Plus_button equals foot elevated button, text equals plus, on_click equals on_button_click similarly for the plus button. Foot elevated button is a button with a shadow that elevates when pressed. Organizing elements with foot row and foot column, foot row, dot, alignment equals foot main axis alignment dot center, spacing equals 10. Foot row is used for horizontal arrangement of widgets. We place minus underscore button, current underscore value, and plus underscore button in this row. Alignment equals foot main axis alignment dot center, centers elements within the row horizontally. Spacing equals 10, adds 10 pixels of space between each element in the row. Foot column, dot, horizontal underscore alignment equals foot cross axis alignment dot center, spacing equals 30. Foot column is used for vertical arrangement of widgets. We add a title, foot text, your counter, and our row underscore controls to this column. Horizontal underscore alignment equals foot cross axis alignment dot center, centers the content within the column horizontally. E.g. our row underscore controls will be centered. Spacing equals 30, adds 30 pixels of space between each element in the column. Row and column are powerful containers for building complex layouts. Adding the main element to the page, page.add, and updating the UI, page.update, page.add, column underscore layout adds the created column underscore layout, which contains all other widgets, to the page. Page.update, this update call is necessary here to initially display all elements on the page when the application first starts. Running the Flet application, foot app, target equals main, view equals foot web underscore browser. Foot app, this function runs your Flet application. Target equals main, specifies which function is the entry point for your application, in this case, our main function. View equals foot web underscore browser, this argument tells Flet to open the application in your web browser. This is convenient for rapid development and testing, as the browser can be automatically refreshed when code changes. If you want to run the application as a regular desktop application, simply remove view equals foot web underscore browser, leaving foot app, target equals main. Example 8, building a simple to-do app. This example combines multiple controls and event handlers to create an interactive application. Step 1. Create an input field for a new task. Step 2. Create a column to display tasks. Step 3. Define the function to add a task. If the input field is not empty, checkbox text is the task text. Add the checkbox to the tasks list. Clear the input field. Update the page. Step 4. Create a button to add a task. Step 5. Add the elements to the page. Input field. Add button. column to display tasks. Step-by-step explanation, new underscore task underscore input equals foot text field, dot field for task text input. Expand equals true allows it to take all available space in the row. Tasks underscore view equals foot column, an empty column where tasks will be dynamically added. Def add underscore task, handler for the add button. If new underscore task underscore input dot value, check if the user entered something. Task underscore checkbox equals foot checkbox, dot create a new checkbox for each task. Tasks underscore view dot controls dot append, task underscore checkbox key point. Dynamically adding an element to the controls list of a column. New underscore task underscore input dot value equals, clear the input field. Page dot update, update the UI. Add underscore button equals foot floating action button, dot. A floating action button with an icon. Page dot add, foot row, dot, tasks underscore view. Add the input field and button to a row, so they are on the same line, then the column for tasks below them. Example 9, Container for styling and spacing. A container is a versatile control that can hold other controls and apply styles like background, padding, and margins to them. Step 1. Create a text control inside the container. Step 2. Create a container and add the text control to it. Content of the container. Internal padding. External margins, only top and left. Background color. Alignment of content within the container. Rounded corners. Inkwell effect on tap. Click handler. Step 3. Add the container to the page. Step-by-step explanation, contained underscore text equals foot text, dot create a regular text control that will be inside the container. My underscore container equals foot container, dot create a container. Content, accepts a single control to be placed inside the container. Padding, internal padding, space between content and container's border. Margin, external margins, space around the container. Foot margin. Only allows setting margins for individual sides. Color, background color of the container. Flet provides many predefined colors via foot colors. Width, height, dimensions of the container. Alignment, alignment of the content within the container. Border underscore radius, rounded corners. Ink equals true, on_click, containers can also be interactive and react to taps. Page.add, my_container add the container to the page. Page.update, update the UI. Example 10, changing page theme, dark/light mode toggle. This example shows how to programmatically switch between light and dark themes for your application. Step 1. Set the initial page theme, e.g. light. Define the function to toggle the theme. If current theme is light, switch to dark, otherwise switch to light. Update button text. Step 3. Create a button to toggle the theme. Step 4. Add the elements to the page. Step-by-step explanation, page.theme_mode equals foot theme mode.light, set the initial theme mode of the page. Foot theme mode provides constants for light and dark modes. Page.update, update to apply the initial theme immediately. Def toggle_theme, e-button handler. Page.theme_mode equals foot theme mode.dark if page.theme_mode equals foot theme mode.light else foot theme mode. Light, this is a ternary operator. It checks the current theme. If light, it sets to dark, otherwise it sets to light. e.control.text equals. Update the text on the button itself so it reflects which theme the button will switch to next. Page.update, update the UI to display the theme changes and button text. Theme_toggle_button equals foot elevated button, create the button. Conclusion, in English. The Flet library opens up immense possibilities for creating cross-platform applications in pure Python, without the need to learn other languages or UI frameworks. You've seen how easy it is to create interactive elements, manage layout, handle events, and even dynamically change the state of your application. Practice exercise, using the concepts learned, try creating a small calculator application that takes two numbers and performs basic operations, addition, subtraction, multiplication, division. When buttons are pressed, displaying the result on the page.